In this particular question, there is a block of mass small m 2 kg which lies on a mass capital M which is of 8 kg. That is, the wedge has mass 4 times the mass of the block. We need to find the initial acceleration of the wedge if the surfaces are smooth and pulleys and strings are massless. So we need to find initial acceleration of the block and the wedge. So to find initial acceleration, first of all, we need to find a relation between acceleration of block and wedge. So to find this particular acceleration, let us assume the length of the string to be L1 plus L2 plus L3. At a particular instant, let the wedge moves forward by X and the block slips down by Y. Then what will be the relation of X and Y that we need to find first? So there are three parts, L1, L2 and L3, and this angle is theta, where theta is given to be 60 degree. Now at a particular instant, the block moves down by Y, the wedge moves forward by X, so top of the wedge also moves forward by X, and the string becomes like this red dotted line, such that length of this particular portion of string is x cos theta. Now if we try to find the constraint relation, we can write L1 plus L2 plus L3 is equal to L1 plus Y plus L2 minus x cos theta plus L3 minus x. So here from we can write 1 plus cos theta into x is equal to y. Theta is given to be 60 degree, so cos theta is half. So we have 3 by 2x is equal to y, or 3 by 2 d2x by dt2 is equal to d2y by dt2. That means if we consider acceleration of the wedge to be a, then acceleration of the block will be 3 by 2a, as it can be seen from here. d2y by dt2 is equal to 3 by 2 into d2x by dt2, that is a. Now we write the equations drawing free body diagram of wedge and block. For the wedge, the forces on it are tension T, the normal reaction exerted by the block on the wedge, the tensions due to the pulley on the top of the wedge. This angle is given to be 60 degree. So for this particular wedge, we can write T minus n sine 60 is equal to 4m into a. This is the equation for the wedge. For the block, if I consider the forces, its weight is acting downward mg, a tension is up the incline, a normal reaction n is perpendicular to the incline, and due to acceleration of the wedge, it is experiencing a pseudo force in horizontally backward direction, and the angle made with the normal to the incline and vertical is 60 degree. So if we try to write equation for the block, then we can write in Along the incline, its acceleration as we found is 3 by 2a. So, mg sine 60 minus ma cos 60 minus t is equal to m into 3 by 2a, and as with respect to the wedge there is no motion of block perpendicular to the incline, so perpendicular to the incline the net force is 0. That is, we can write normal reaction N is equal to mg cos 60 minus ma sin 60. So now we have three equations and three unknown t, n and a. Solving these equations, eliminating t and n, we can find acceleration a to be equal to 3g root 3 by 23 or 30 root 3 by 23 meter per second square.